know, I am right along with you every step of the way this year. We will learn chemistry. No matter what, I am prioritizing what is valuable. Now, I know it's from the teacher's perspective, but I promise if I'm asking you to do something, please know it is not busy work. I'm not just going to assign something to assign something because I hated that as a student. So we're going to continue to be investing ourselves in this first unit. So our first week was getting us like just gently familiar with how the class was going to be run, but then we were looking at lab equipment and safety guidelines. When we get back to the classroom, we will be in lab. I cannot believe we were denied getting a hands-on experience with our Bunsen burners today, but when we get back in the classroom, we'll be doing that lab. All right, so this week, we're just going to continue on learning the content of Unit 1. So what I'd like to do today with us, just in our 40 minutes, I just want us to take a look. This is a great additional advertisement from the Science Channel, but I hope it just reflects the way I'd like us to be approaching chemistry, and it's just talking in general about science. So I want to make sure what we discussed yesterday is clear. So are we just good on the general steps of the scientific method, difference between a theory and a law? And when we say science is different in how we get our knowledge, do we understand that? We'll define chemistry today. We'll open the floor to any questions you might have about what are the properties that all matter has in common. So things on the Edpuzzle video. And I have a couple questions for us to answer. And then we'll talk about, well, where do we go next? And that's with the states of matter. All right. Okay, so I hope I've controlled the settings and that you will be able to, oh, we have some other people joining us. So remember I asked us to look at those like virtual etiquette. I know when I log into Zoom or any kind of conference, usually there's lag time in getting there. So please, I'll just ask that we be on time because I only get you for 40 minutes live. So we want to make sure that we're getting on time. And I know that there's some lag time and everything else, but let's just do our best to arrive at 11:24. I believe I've set all the settings where I need to. I pray. And I pray the sound will come across to everyone. If not, just enjoy the visuals. Did the screen change for you? Can I see a thumbs up? Okay, great.
This is probably what you think of when you hear science. So let's change that right now. Let's go.
I hope we heard sound. Okay. So what that was a tour through a lab. So I think, we often have the stereotypical look of what scientists do in lab. And did you see there wasn't one person in a lab coat or with goggles or, in a room all by him or herself? They're regular people. And I'm sorry that you didn't get to hear the audio because he says toward the end, we are science. And so I just want to encourage us to know that we are the scientists of today and the future. So I pray that we're kind of, looking a little differently at how we're going to explore science this year. So science is this great body of knowledge, but what makes science different is how we get that knowledge. You know, I love that quote I shared with you. We just have to know, as I said yesterday, I will never ask you, what are the steps of the scientific method? Write them out. We just have to know in general what is included and in general what the order is. So a question may come your way, ladies and gentlemen, that's a multiple choice that may read something like, all of the following are included in the scientific method except for. The following statements below represent how science is different from other subjects. And so if you just paid attention to what we talked about yesterday, then you are so good to go. If you have the Unit 1 packet, now I'm going to scan it and repost it on Canvas for us, but within that packet, so in the first page was science and the quote of science, but then there's just an image that shows us the branches of science. So I'm sure you've gone through this before. You know, we have this big body of knowledge we call science, and then science differs in how we get the knowledge, the scientific method, but then we get more specialized. Chemistry and physics are physical sciences. They study matter, forces, and energy. Now, there's actually different types of chemistry. We'll get back to this. But if you could please jot down this definition of chemistry. This, I pray, will just keep coming more and more and more to life over this school year for us. Chemistry is the study of the composition, structure, and properties of matter, the study of the composition, structure, and properties of matter, and the changes it undergoes. So what does this mean? So to bring to life, you know, and if we could come back at the end of the year and revisit what I'm going to explain, you'll really see that I am holding true to these words. Okay, so if I could use an example, I have some images there. One of my favorite tools as a teacher is my chalk and my chalkboard. I'm a writer downer as I teach, which will really be shown to you in the next couple of weeks. That's just the comfort that I have as a teacher. So man, I love my chalk. Okay, so if we have a piece of chalk, what are we talking about as far as what we would learn chemistry-wise about that chalk? Well, the study of the composition. By composition, we're looking at what is it made of. But what does that mean? Well, for chemists, it's the periodic table. What elements make it up? And for chalk, you don't have to know this now. Chalk is made of calcium, carbon, and oxygen. So what are the elements that make it up? And then how are those elements structured? And you can think of like building with Lego blocks. Actually, we'll find out very soon that calcium, when it reacts, loses 2 electrons to form a positive 2 cation. Then it will electrostatically attract carbonate, and we'll learn all about that. Well then, how are those ions built in reference to each other? Are they in a cube with the ions as corners of the cube? Is it a cube with the ions on the faces? Is it like a diamond shape? So what is it made out of? And then how are those pieces put together? That is what determines properties. So we all know we can write on the chalkboard with chalk. So what enables that? It's what it's made out of and how it's put together. Why, when I exert a little bit of force, does chalk break in half? Because of the composition and the structure. Why is it a solid at room temperature and pressure and not a liquid or a gas? Because of what it's made of and how it's put together. And then the fun part. How can I change it? So what happens to the chalk if I heat it up slightly? Or what if I strongly heat it for a long period of time with very high heat? What if I put it in water? What if I put it in a beaker of acid? So what is it made out of as far as elements or compounds? How are those things put together? What properties result? And then what experiments can I do? Can I make something new? Or can I maybe unmake something that's harmful? So that's what we'll be doing. Now, there's different kinds of chemistry. You do not have to know these. They are communicated in your book. I just want to make sure that we just know what we are studying this year. So you will never be asked, what are the different types of chemistry? No. We just have to know the type of chemistry we are learning this year is called inorganic chemistry. So I often will say, in our type of chemistry, inorganic chemistry, that is our perspective. We're studying all the elements. So other types of chemistry have their priority maybe on a single element and the compounds it makes, like organic chemistry centers on carbon. Biochemistry really looks at the intersection of biology and chemistry, particularly concerned with life. So a lot of like cell operations and that kind of thing. So inorganic chemistry is our focus, and that is the foundational layer of chemistry that every chemist begins understanding before they get any more specialized or just go deeper into that field. So inorganic is our area. That's all we have to know. We just study all the elements. No preference. Okay. So I had asked you to watch an Edpuzzle video, which just addressed, okay, what is matter? And if we say something is matter, what properties do we know it has? If we say we have two samples of matter, what properties do they definitely have in common? I think a good measure of our understanding is by addressing a couple more questions. So on the next slide, we'll see 4 multiple choice questions. On average, a multiple choice question should take about a minute to think about and respond to about. So why don't we take 3 minutes, go ahead and read through, come up with your answers, and then we'll share them and talk about them. All right. We'll take 1 more minute. All right, number 1, D. So we absolutely, the only device that measures mass is a balance. We use a scale for weight. Any version of a gram. And so we will remind ourselves of the metric system next unit, but those prefixes are attached to the base unit. So kilogram, megagram, centigram, gram, those are the appropriate unit. So it can be expressed in kilograms, absolutely. C is the definition. So D, best choice. Number 2, mass. Mass is constant no matter where you take your object. Now, you could have friction, like remove some, but we're just talking about, in general. So mass is always constant. However, weight can change depending upon the pull of gravity. The further you are from the center of an object, the weaker the pull of gravity. So if weight is a measure of the pull of gravity, the stronger the pull of gravity, the greater the weight. So it'll be least B, the higher you are. And we're talking about from the center of the earth. Okay, 3 is A, and 4 is D. We will talk about malleability. Malleability is the ability of a substance to be pounded into thin sheets. That's the true definition. But the application of this, metals are malleable. You guys know you can take aluminum foil and you can bend it and curl it around the edges of your brownie pan. That is malleability. Not everything can do that. Only metals can. So I couldn't do that with my chalk. I can't bend it around a corner, it'll break. It's brittle. The opposite of malleable is brittle. But everything else is associated with matter. Does anyone have any questions on those questions or on, I'll start sharing the screen in just a moment, or anything from the video that you watched? Oh, okay, Porter, I just saw, so I don't know what's going on. Was that from the commercial, or I'm so sorry that I'm pronouncing to everyone, of course, what you wrote in the chat.
That was from when I was like in the weird bridge phase.
Okay, so are you all good, sir?
Yeah.
Okay, perfect. I know from teaching all last spring that there's, I don't know, real hesitation to speak up when we're in these virtual sessions or even to type something in the chat. But we're here together to learn through this great subject. So please, if there is a question, and if you're terribly uncomfortable, you can always email me.
I have a question.
Please,
So,
Justin.
for what was the question about malleability? I thought that would be volume, because I thought volume was just for liquid containers. Is for everything?
Okay, so volume is just by definition the amount of space an object takes up. The amount of space an object takes up. So if you think of any example just around you of matter. So my pen, now this I would say is a solid, and I could actually measure, I could say it's a cylinder, and then I'd need to measure my dimensions, the height, the diameter, and so on, to actually calculate its volume. It takes up a certain amount of space. I can't put my watch into the pen or have it exist in the same space at the same time because it takes up space. Just like I said in the video, like if you're sitting in your seat right now, if your dog tried to sit in your seat while you're sitting there, your dog will end up sitting on your lap because you take up space.
Okay, I think I get it.
Okay, but so does a liquid.
Sure. Yeah.
Think of a balloon and imagine like, evacuating the balloon so it's nice and flat, but then filling it with liquid water. It takes up space then, yeah? Or you could blow into it and you're filling it up with gas. So all samples of matter, that is a characteristic that we know is associated with all matter, that it takes up space. Is that better?
Yeah. Thank you.
Perfect. What else? And please, always ask, especially if I'm using a term that we're unfamiliar with. Now, not often in a multiple choice question or a test question do I include a term that we haven't talked about. However, if you remember the lab safety quiz, there was odorometer, I think, as a choice. I'm pretty sure I made that up. I don't think there's such a thing. So wrong answers, often teachers call them distractors. They're trying to distract you away from what the right answer is. And so we know what we've heard in class, we know what we've read. And so if you saw that malleability, I'm very careful with what common knowledge I expect you to have. Okay, so including terminology. So like if that was a test and you're like, wait, I'm not really sure what malleability is, you can always ask me. Okay, so that's just an example. Okay, so any concerns before we pick back it up?
Yeah.
Please.
Can you explain the difference of potential and kinetic energy again from the video last night?
No problem at all. Okay, I will definitely be the first to say, energy is one of those things that, we know what it is, but can we really put it on paper and really say to the depth of our soul that we get it? So energy is usually the ability to cause change or do work. But what does that mean? So I think when we talk about the forms, that's a little bit easier. Okay, so energy is either kinetic or potential. We say kinetic is energy in motion, potential is stored or due to position. So if Joey, do you have a dog?
Yes.
Okay, so let's say that your dog is running through the yard chasing a rabbit. Well, that's energy in motion. There's movement. And so we would just say that's kinetic. Now, your dog has ingested food to be able to supply the energy needed to the muscles that then is expressed as motion. So when we say potential energy is stored, well, it could be the energy that's stored in the fat, in the carbohydrates within the dog that then is tapped into to become kinetic, energy of motion. As far as we're concerned in chemistry, usually when we're talking about energy, we're talking about energy in the form of heat, most often. So we're talking about reactions that release heat or absorb heat, are exothermic or endothermic. And what we have to understand is that form of heat is coming out of bonds being broken and bonds being formed. That is just where we are. So what is energy? Ability to cause change or do work. But how does that relate to chemistry? Well, we say kinetic energy is the energy of motion. So like a dog running, that's a great example. You walking down the sidewalk, great example. But how does that apply to chemistry? Well, usually we're looking at heat being released or absorbed during a physical or a chemical change. Heat is a form of energy. Where's that coming from? Bonds being broken or being formed. So when we say, energy is stored, it's within the bonds. That's potential energy. And then that gets communicated kinetically as heat.
So potential energy turns into kinetic energy?
Yes.
Okay.
Yeah, have you seen, I don't know, maybe since 7th grade, you know, you have a hill, and you know that if you have a rock on the top of the hill, that it's going to sit there until an unbalanced force acts on it because it has inertia. But then, woo, and it's going to go faster and faster and faster. So we could say this has a certain stored energy due to the position. And then it starts to move. Well, where'd that energy come from? Potential. So energy is conserved just like matter is, but we can change forms. Potential becomes kinetic. Kinetic comes from potential. Does that make sense?
Yeah.
We won't do calculations with heat yet or with energy yet. And when we do, it will just be with heat. So as long as we just have a surface, and we're never really after surface, we want to go deep, but with energy for now, we're okay with just the general broad definitions and just seeing, oh, chemistry is really going to get to potential energy that then is often released as heat. I hope that's better.
Yeah, it does.
Okay. Anything else? Great, great questions. Great, great questions. Okay, don't hesitate to ask if needed. All right, so if we go back to this, these were the questions we just looked at. Okay. So this chapter was about, all right, we're studying chemistry. Chemistry is a type of science. Well, what is science? We need to make sure from the chemist's perspective, we understand how science is different. And then what is chemistry? Well, chemistry is the study of matter and the changes it undergoes. Okay, so what is all the stuff we know about matter? And that's what we watched last night and then just talked about. So now the states of matter. And I think easily we could say, ah, this is Gerhardt. That's so easy. This is a marble. A marble, easy, solid. Cup of lemonade, oh, liquid. A book, solid. Oh, a balloon, that's a gas. So I think there could be some more challenging, but in essence, I think around us, surrounding us, if we look at all the samples of matter, it's very easy to categorize what state it is. But do we know from the chemist's perspective what really determines why something is called a solid? So I think saying something is a solid is very different from understanding why it's a solid. Or we say that liquids have an indefinite shape. What does that mean? And do we really know why that is? So that is where we're going next. Okay, so I just snipped a portion of module 1. So you can look at this as like the in-class work, if you will. So here are just, the different tabs within module 1. And so here was, matter. And now we're on to the states of matter. All that you need to do is open up this page. And there's 4 things that you'll do on that page. It will take maybe 15 to 20 minutes, maybe. So the first thing that you'll do is you'll see number 1, and it talks about this animation. Please read the instructions because that's all that I'm asking you to do is what I put as instructions. Then you'll go into the animation and just do what I've asked. And please, you have my full permission to adventure more if you would like, but you don't have to. So all that I'm asking you to do in the first little animation is just follow my directions. Then there's another animation made from the same host or sponsor, and you're just going to follow my directions. So each one of those might take 60 to 80 seconds, but do feel free to play around because you'll see it's kind of just neat. and it gives us a good visualization of the particulate level of the states of matter. Then I have just a quick discussion post, and it's in that same page, so you never have to leave that page. Then I have a video. It's not an ed puzzle. It's a video. Feel free to speed me up, stop me, but I encourage you to jot down some notes. In fact, in the video, I make boxes with particulate diagrams, and then I create kind of a chart of properties. And I encourage you to replicate that yourself. Doing that, I think, will help connect the information, but also then be a resource for you moving forward. So how do we know that we got what I wanted us to get from the animations and then from the video? There's check your understanding questions. They're embedded in that same page. Now, I definitely know it'll feel like a quiz. I'm giving you completion points. Completion points. I know you won't blow it off, but I know you won't blow it off. But I ain't going to worry if you get something wrong. We just want to learn from our mistake. So I think there's just 5 questions, but they'll give really good pinnacle, they'll cause us to really think about this knowledge. Okay, so once I'm done talking and you guys get any questions answered, you'll go into Canvas, go into the States of Matter page, to animations, just follow my directions, discussion post, watch video, answer the questions. Again, take maybe 15, 20 minutes. So that's our kind of like classwork today. By class time tomorrow, so our homework is there's an Ed Puzzle video. So when you log into Ed Puzzle, and this gives us the foundational teaching so that tomorrow when I'm with you, we can dig right in to chemical and physical properties and changes, get examples of these. Computers keeps rudely interrupting me. All right, so we're taking a look at this information. You know, at any point you can reach out with any questions. So, you know, you're completing 3 things for me today, and that's discussion post, those check for understanding, you'll get a score for completion, and then the Ed Puzzle video by class time tomorrow. Now, we are at the end of our time. These slides are on Module 1, so if you need to go back to look at anything we looked at, and you know that I'm here to address any concerns or questions. Okay, so as we end, again, it is so great to see all of your just very handsome faces and beautiful, beautiful faces. Thank you. I think, I hope that you guys are doing okay. I'll definitely repeat the homework one more time. I hope we're doing okay, hanging in there, because this is a strain, just emotionally. Just wearing masks is such a strain. Then we add to it the social distancing, and then, oh my gosh, we're home. And you may have had lag time getting into Zoom. So if anyone feels like they need to get a grouch out, I definitely will listen. We just don't want it to be a big negative session, but I'm right in this with you, and I will help support you, and we will learn chemistry. Okay, so the homework is the states of matter. Well, this is like the homework. States of matter instruction page in, oh crud, can't even spell. Instruction page in Module 1. So you're just gonna open that and go through that. And there'll be a discussion post and a little question set that you'll answer. And then there's an Ed Puzzle. And whenever you log in, you'll see the next one. gorgeous day. The sun is shining. Let me know if there's any concerns or questions. Otherwise, I will look forward to seeing you guys tomorrow. Thank you very, very much.
Thank
Have a great
you.
afternoon. You're so welcome.
Thank you.
You're welcome.
Thank you.
You're welcome. Bye-bye, guys.